So for tonight's program, I am going to turn this over to Dave Bonneau of Enginasion, and the co-moderating tonight with Jerry Shapiro of Floel, two very experienced entrepreneurs with great backgrounds. I won't bore you by reading you what's in the program. You can check that out. But they put together a great program tonight, which is going to be really informative, and I can't wait to hear it. So, without further ado, I'm going to turn the rest of the program over to Dave. Thanks.
Gentleman Dan Leary couldn't make it tonight. He has back problems, and he's a dear friend. I've been working with him putting together a system for monitoring solar installations throughout the country. So Dan came up with a sensor here, which has two separate sensors, both standards in the industry, because this is a low power system, which is really part of Internet of Things. You have sensors and you have radios to get that information back into the cloud, and then you have cloud. And these sensors are run by very low power computers that can effectively, with recharging, because we've got sun, so that's kind of neat, we can run the sensor for about 5 years on a battery. That information goes back to an aggregator like Jonathan's company, Sine Wave company. They have servers and they aggregate all this information, put it together in a form that the utilities can use. So the utilities can generate a map of what's really going to happen in the next 2 hours and use that information to decide whether or not to power up these generators, which can cost millions of dollars to do. So Dan has worked for quite a while generating money and generating electronics and software to put this whole system together. This is what it looks like in a little bigger scheme. This is a solar installation, a very small one, and he's doing some testing here of these sensors. So that's kind of where it comes in. These sensors install in between the panels. It's very easy to do. The important thing is to get a lot of these into the field so you generate a more accurate map. And this is the idea behind the Internet of Things, is to take information which you would not usually be able to use because it was so scattered, aggregate it, put it into a form that actually gives you some information. Here's another system that goes into an Army helmet or a service helmet for a soldier. It's made of flexible material. The components aren't on there for reasons of security. The idea here is that they'll take an Army helmet and grind out space for these sections. And they'll put those sections in the helmet with accelerometers and temperature sensors and pressure sensors, shock sensors, and radio that out to the cloud. So why? Well, they're finding out that Humvees, which are exposed to IEDs, you know, those bombs in the road, because the fact that many of them are closed and they're airtight in the sense of they want to keep chemical weapons out of the trucks. They want to make it safe for breathing. That's great until you get hit by a bomb and the whole thing becomes a big resonator. It's kind of like sticking your head in the bass drum of some guy whacking at it on stage. Right, Jonathan? So, and what happens is when you set up that cavity to resonate, you get these little standing waves. And those standing waves can be big and tiny. And they're finding that these tiny standing waves can actually turn your brain into jelly in places. So that's information they never would have had unless they could see a lot of information from a lot of people. Hopefully, they can aggregate this data over a long period of time, find out what's causing it, how do they prevent it, and so forth. The reason I'm going through this detail is just because I know we have some technical people here, and it's kind of nice to look at the whys of why we have all this. Manufacturing systems, there are companies now that have Bluetooth and radio-based tools gathering data in manufacturing environments. The idea there is to develop quality control systems, make sure people are in the right places at the right times for those machines to be run optimally. They can also track people in the factories, what machines they should be, in places where they have toxic chemicals that they're working on or toxic environments that have to be done in hoods. If you have a radio monitor on your coat or in your badge, you can now track the people that are around those toxic chemicals to set off alarms that they're not properly trained for those, so forth. This is kind of a complicated thing. It's a remote control for cell towers, and it establishes some critical parameters of the receivers and the transmitters. So here's a case where we have a lot of information going to these towers, but what about the towers themselves? How are they doing? I guess I heard a story about EMC, that they were considered very reliable within the industry. Part of that is the fact that they're monitoring their databases all the time. Other companies didn't do that. So if they're monitoring their infrastructure within their client's environment and they see something happening, if they can fix it first before the customer even recognizes it, and that's uptime, isn't it? Things that we hadn't have thought of, RFID tracking and data storage. RFID is what, radio frequency identification. It can put it under the skin. We're now putting it in metal dies for rolling machines where they're rolling screws, putting it in metal cavities, putting it in other kinds of environments. They're getting bigger and bigger to the point where it's not just an identification anymore, like when you drive through the Easy Pass on the highway. The transmitter sends a signal to here. It gives it some energy to charge up and send a signal back. Well, now we're getting tremendous storage in these things as well. So we're actually storing information in them. So we have products that might be used in a machining operation, that a die or something that wears out. So we can track that right within the unit itself. You know how many cycles it's been through, when it's going to explode, when it's going to go out of spec, so that device can actually signal the tool room to come and replace it out, send it back to the manufacturer for refurb. A lot of what we're seeing now are Bluetooth low energy, which is a Bluetooth that you have in your cell phones. There's a low energy version now that can, with a pretty big battery, you can easily go a year on it. XB radios, Zigbee radios, that's another kind of form factor. Part of the problem in dealing with radios is that each one of them has to be approved if you're going to put it in your equipment. Now companies are coming out and actually providing modules that you can build your computer and then plug the module in, it's all approved, and you've saved yourself $20,000 to get into production. Tracking location and recording. I believe it's this particular system that Lindsay Lohan wears on her ankle. Yeah. It's an alcohol sensor, and it's through the skin, and they work pretty well. The idea is that it used to be, about 10 years ago, the idea was that it would store the information, and when the person came home, all that information would get beamed up to the parole officer. There'd be a server in the house. That information would get pulled in by the server, and then it would go to an aggregator and then sent to the parole officer. Now, actually, they're direct, right to the parole officer, real time. This is something that's new. That's a shot of an Android tablet. And this is the screen for an in-home oxygen generator. Actually, hydrogen generator to refuel your car. It's 5,000 pounds per square inch. And it's run by an Android tablet. This is one of the first surgical lasers. It's a dental laser. I had to blur it out so that, just for the client's concerns. It's an Android laser for periodontal disease, and it's being run by an Android interface. So what do you do when somebody's got something that could be a cell phone running a computer? So all those things have to be addressed. Patient training at home. The little boy, it's not quite intuitive as to how to use a breathalyzer for asthma. So now we have applications that they can lend that to the patient, and they can use it at home to practice so that it's more effective when they breathe. And you just use your cell phone for the app. So it saves a lot of money. This is really weird. This is a guy I met. He came into our office. He was wearing one of these court jester hats, and he had shoes. It's about 75. Wonderful man. He had shoes that lit up when you walked. And he has this thing, it's subliminal messages. So he can, if you look at it just the right way, you can see this picture, and then underneath it there's a message going on. Well, the Chicago Transit Authority wanted to be able to send messages to people in subways going 55 miles an hour without putting terminals in the subways. And it just so happened that this gentleman's technology, it's made of spars. And it's almost like you would see on a video screen, but it's columns. It only takes about 8 columns, and it's just one LED stick. They're about 4 feet long, spread over about 18 feet apart. And so what he does is he senses the speed of the train and then fires these columns and creates an image. So they're looking out the window. He's photographing this with his left hand, with his right hand. But that's actually out of the window on the wall of the tunnel. And that's pretty cool. So, why Internet of Things? Well, in order to go into a tunnel, you have to give at least 6 months in advance notice to the transit authority so that they can get all the permits and put you through the process, the training process, to allow you to go into a tunnel and not end up roadkill. So they asked for this system. It took about 6 months to install it. And what do you do if it fails or it's having trouble? So he had to make it bootable because he can't go in. So he had to have it remotely bootable. Very reliable to begin with. The wiring had to be run in the tunnel. It's a combination of wiring and radios. So there's a lot of infrastructure just to keep it running, and not if it fails, but when it fails, how do you get up and running again? Do you put in dual computers? So that's kind of the environment that I'm trying to express here. And Paula will be talking about a much more severe environment, and particularly the funding on that. And then Jonathan will be talking about the aggregation of all this information and the way he funds it. So any questions?
What was Internet of Things called before that name came out? Was it machine-to-machine communication?
Yeah, I suppose M to M. What do you think? You guys have been in it very long. Machine to machine, M to M, Jonathan?
I mean, the Internet of Things was coined 14 years ago, so it's actually been around quite a
Okay.
while. It was coined over at MIT. I think the difference is that M to M, in my opinion, tends to have the connotation of almost point-to-point or just remote control of machines, whereas the Internet of Things, while it's assimilated the concepts of M to M, it's how do we approach solving problems differently by extending our understanding of what the Internet is. It's not just plugging in things to the Internet. It's about really extending our reach in trying to make sense of that information. So I think it's not just a technology, it's also the change in the way we approach a problem.
Okay, thank you.
Yeah.